In our last webinar, we started discussing inventor automation and the inventor automation, the data flow of creating some sort of automation project. So I showed this slide previously. I love showing off this slide because it really gives a good visual as to how information moves back and forth within an automation project, and you know, we're going to be relying on this for understanding in terms of developing our project. So last webinar we discussed about you know, model development, so working within our inventor library. In this webinar, iParts and iAssemblies follow, you know, a similar methodology to some degree. You know, we're going to be creating iParts and iAssemblies as necessary. And we're going to be placing them in this inventor library. So understanding where the library comes into play, what part does it play in this project? So understanding how this flow works and where our iParts and iAssemblies reside and how we're going to leverage them is absolutely critical for creating a successful automation project. All right, so iParts and iAssemblies. iParts and iAssemblies, they've been around in Inventor for quite some time. And essentially, I mean, if you're coming from some other CAD platform and maybe you're not familiar with the terminology, iParts, iAssemblies, essentially all they are, guys, is they're table-driven components. So either table-driven parts or table-driven assemblies, a means for us to easily develop components that are of a like configuration. As an example, you know, a fastener. Take a quarter 20 screw or bolt rather, as an example. Now, a quarter 20 bolt can be of numerous lengths. However, you know, maybe the thread size and the thread diameter is similar, but maybe the length is different, or even a fastener in general. You know, aside from the length and the diameter and the type of head it may have, the configuration itself is exactly the same. You know, it's a shaft and it has this thing on the top that can be of a different shape. We could essentially use parameters and properties to control those different lengths, diameters, and sizes via using a table. So iParts, iAssemblies, let's just take a real quick look over here inside of Inventor just to give you a visual of what I'm talking about here. So I have Inventor 2019 open up. In the background, I have an idler wheel that I've created many years ago. This is an iPart. So if I look over in my model browser here on the left-hand side, where my cursor is here, we have this table in our underneath our top level in our model browser here, where we have different belt widths that I've indicated. So if I want to go to a different belt width, all I need to do is simply, you know, double click to activate that particular size, and then my model is going to respond and react appropriately based upon the information that is associated to that belt width size, so 24-inch size. So you'll see that my model now became smaller. You know, different features within my model here changed size based upon whatever's written in the table associated with these sizes here. So what does that look like? If I right-click in my table here, I have a menu where I can go and I can create a new member, edit via spreadsheet. We're going to be focused on an edit via table here. So it's going to open up a table inside the context of Inventor here. So that way I can understand what's happening. So my different members, my 24, my 30, 36, these items that are represented in my browser here are nothing more than different rows in my table. The different columns represent either different parameters or properties that I want to either read or I want to manipulate at some point based upon the different row that I might have highlighted. So in the case of a 36-inch idler, I want my belt width to be 36, my slot length to be 45, so on and so forth. I'm not going to go in too deep into the entire ins and outs of developing iParts and iAssemblies, but just to give some frame of reference of why we want to even use iParts is simply because of this right here. I have an interface that I can use to add and remove different properties and parameters, and based upon that iteration or that row, I can then specify different values. So as I activate those members, those values will then be put into place, and it's going to then change my configuration. So going back over to the spreadsheet here, the benefits of iParts and iAssemblies, as I just demonstrated there, it's very easy to develop. So if I need to create new iterations or new configurations, it's nothing more than adding a new row to the table and then filling in the appropriate values. They're very user-friendly. If I need to change anything, if I need to go to a different component, all I need to do is simply double-click. So I don't have to go and browse out to find a new component, understand its file name, and bring it in and do a component replace. All I need to do is just simply activate the iteration in which I want for that design, and then go on to the next one. So extremely user-friendly. And it's easy to update. If I need to change a value, either a property value or a parameter value, I can simply go to the table, make that change, and now I've updated my design in that regard. So extremely user-friendly, extremely easy to use. There's a lot of benefit involved. So if you get an opportunity to, within your design environment, if you have instances where you have configurations that are similar in nature, but maybe just slightly change values based upon different part numbers or different iterations, well, then maybe iParts and iAssemblies are a way for you to accomplish that. Now, when working specifically within design automation, they can be powerful and they can be leveraged in that regard as well.